Announcing the arrival of the honored speaker, Professor Dr. Hajah Hamidah Muhammad Saman, Dean of Industry, Community and Alumni Network, College of Engineering UITM, accompanied by Honorary Div to enter the hall. Ladies and gentlemen, please stand up. National Anthem Negaraku and Wawasan Setia Warga UITM.
Bersatu kita warga UiTM, kita bangsa perkasa, taat dan setiaku untuk negara, penuh semangat wajar. Kita jangan mudah terlupa pengorbanan perjuangan anak bangsa. Kita jangan mudah terleka kemajuan keamanan yang ada. Kita berterima kasih pada pemimpin-pemimpin negara. Kita rasa penuh bersyukur kerahmatan kemuliaan darinya. Kamilah pendukung pewaris bangsa, kamilah penerangan bangsa Malaysia, kamilah warga berwawasan untuk negaraku.
Thank you. Please be seated.
Hamidah, besar nanti awak nak jadi apa?
Entahlah awak. Tapi kan saya rasa saya nak jadi profesor.
Yelah tu, boleh ke?
Awak ni selalu sangat orang cakap macam ni dekat saya. Kecil hati saya tahu. Besar kecil saya tengok awak ni, Lausna. Tengoklah, satu hari nanti saya akan buktikan dekat awak yang saya akan jadi profesor terulung. Masa tu baru buntang biji mata awak, Usna.
Mida. Semoga awak berjaya lah, ya.
Yelah, okeylah. Okeylah, saya nak balik. Bye.
Bye.
Bismillahirrahmanirrahim. Yang berbahagia, Profesor Dr. Hajah Hamidah Muhammad Saman, Dean of Industry, Community and Alumni Network, College of Engineering, UiTM. Yang berbahagia, Profesor Surveyor, Engineer Dr. Haji Suhaimi Abdul Talib, Assistant Vice Chancellor, College of Engineering, UiTM. Yang berbahagia, Profesor Teknologis Dr. Wardah Tahir, Director of Curriculum Affairs, UiTM. Yang berbahagia, Major General Datuk Pahlawan Engineer Haji Capiti Haji Rizwan, Director General Markas Angkatan Tentera Malaysia, Bahagian Perkhidmatan Kejuruteraan Pertahanan. Yang berbahagia, Datuk Engineer Roslan Ahmad Zainuddin, Presiden Civil Engineering Alumni Club, Datuk Teknologis Dr. Ahmad Ruslan Muhammad Rizwan, Orang Kaya Panglima Bukit Gantang, Sri Amar Diraja, Ahli Dewan Negara, Perak Darul Rizwan, Deans, Deputy Deans, Directors of UITM, Industry Partners, representative from American Concrete Institute Malaysia Chapter, Concrete Society of Malaysia, alumni, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh, and a very good day, everyone. Alhamdulillah, with all His blessing, we are now gathering in this event for the Professorial Lecture Session by Yang Berbahagia Professor Dr. Hajah Hamidah Muhammad Saman, Dean of Industry, Community and Alumni Network, College of Engineering, UITM. On behalf of the School of Civil Engineering, UITM, and the committee members, I would like to take this chance to thank you all for your participation in this event. Ladies and gentlemen, to seek blessing from the Almighty, we would like to invite Associate Professor Dr. Muhammad Fadil Arshad to lead the prayer recitation. Please welcome.
الفاتحة. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين. إياك نعبد وإياك نستعين. اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين. أعوذ بالله السميع العليم من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين والصلاة والسلام على سيدنا محمد أشرف الأنبياء والمرسلين وعلى آله وصحبه أجمعين. اللهم أحينا بالإيمان وأمتنا بالإيمان وأدخل الجنة مع الإيمان. يا ربنا لك الحمد كما ينبغي لجلال وجهك وعظيم سلطانك. يا الله يا رحمن يا رحيم يا مبدي يا معين يا ذا الجلال والإكرام. We are here today to express our gratitude to you. Let us be your servants who are grateful in our daily life. Ya Allah, Ya Kareem, indeed, you are all knowing that today, in conjunction with the professorial lecture delivered by Professor Dr. Hajah Hamidah Muhammad Saman, we seek you mercy to bless our efforts and causes. Granted us with a value knowledge that will be beneficial to mankind. Please, Ya Allah, guide the College Pengajian Kejuruteraan and UITM to greatness, peace, glory and prosperity. Ya Zal Jalali wal Ikram, please give us strength and perseverance in our quest for knowledge, give us success and excellence in all tasks and achievements that will be before us. Make us your righteous servants that follow your commands and neglect the sinful acts. Ya Allah, Ya Latif, Ya Rahman, please provide us with the good health, mind's vitality, peace of mind, and spirit strength for our members. And with it, hopefully, we are able to meet challenges and be competitive in our professional duty. Allahumma inna nas'aluka ridhaka wal jannah wa na'udzu bika min sakhatika wan nar. Allahumma ful karim tuhibbul afwa anna ya arhamar rahimin. Rabbana hab lana Rabbana du'aana innaka antas samiul alim wa tub alaina ya maulana innaka antat tawwabur rahim. ربنا آتنا من لدنك رحمة وهيئ لنا من أمرنا رشدا ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على سيدنا محمد وعلى آله وصحبه أجمعين سبحان ربك رب العزة عما يصفون والسلام على المرسلين والحمد لله رب العالمين. صدق الله.
Amin, Amin, Ya Rabbal Alamin. Thank you, Associate Professor Dr. Muhammad Fadil Arshad, for the prayer recitation just now. May today's event will go on smoothly, inshallah. Ladies and gentlemen, School of Civil Engineering UITM is delightful with the opportunity given in organizing our today's event of professorial lecture. We would like to welcome everyone and also audience who are watching via the official UITM YouTube channel and College of Engineering FB Live. Thank you and stay tuned to the end of this event. Ladies and gentlemen, now we would like to invite Yang Berbahagia, Professor Surveyor Engineer Dr. Haji Suhaimi Abdul Talib, Assistant Vice Chancellor, College of Engineering, to deliver his welcoming speech, thus introducing our speaker for today. Please welcome, Prof.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good afternoon. Thank you, Dr. Nurbaya Siddiq, our MC. Ladies and gentlemen, allow me to welcome our dignitaries. First and foremost, Yang Berbahagia Prof. Dr. Hajah Hamidah Mohd Saman. It is certainly my privilege to be here to introduce you. Yang Berbahagia Professor Technologist Dr. Wardah Tahir, Director of Curriculum Affairs of UiTM, also representing the Deputy Vice Chancellor for Academic and International. Yang Berbahagia Major General Datuk Pahlawan Engineer Haji Capiti Haji Ridwan, Director General Markas Angkatan Tentera Malaysia, Bahagian Perkhidmatan Kejuruteraan Pertahanan. Thank you for being here, sir. Datuk Engineer Rozlan Ahmad Zainuddin, President Civil Engineering Alumni Club, who has been very supportive of us. Datuk Teknologis Dr. Ahmad Roslan Muhammad Ridwan, Orang Kaya Panglima Bukit Gantang Sri Amadi Raja, Ahli Dewan Negara Perak, Deans, Deputy Deans, Directors of UiTM, Industry Partners, representatives from American Concrete Institute Malaysian Chapter, Concrete Society of Malaysia, alumni, ladies and gentlemen. Allow me to introduce the speaker for today's professorial lecture. Professor Dr. Hamidah Mohd Saman was born on the 9th of October in 1966, Muar, Johor. She completed her primary education at Sultan Abu Bakar Primary Girls' School and secondary education at Sultan Abu Bakar Secondary Girls' School, Muar, Johor. She obtained her Bachelor of Science in Civil Engineering from University of Miami, Florida, USA in 1985. She worked in Getah Indus Sdn Bhd in Tangkak, Johor in 1985 to 1982. She joined Sirim Berhad as a researcher in 1992 and further studied and obtained her PhD in 1999 with a thesis titled Durability of Steel and Fiber Reinforced Plastic in Concrete Containing Silica Fume. She joined UiTM in the year 2000 as a lecturer. Among positions held by her during her tenure at UiTM included Coordinator of Research and Consultancy, Coordinator of Postgraduate Programs for 7 years, Director of Institute of Infrastructure, Engineering and Sustainable Management, ISM, for a year, Head of Quality Management Unit for 7 years, Deputy Dean of Research and Industry Linkage for 3 years, Head of School of Civil Engineering, and currently she is the Dean of Industry Community Alumni Networking for the College of Engineering in UiTM. Professor Dr. Hamidah has supervised almost 30 postgraduate research problems and more than 20 have graduated. Professor Hamidah is a well-decorated researcher, receiving many accolades and awards for her research products. I will now name a few of the many acknowledgements received for her research excellence. Gold and Special Award at the International Trade Fair Ideas Invention New Products IANA, Germany in 2006 and 2008 for her floating dwelling innovation. Silver Award for Coconut Particle Board product at the Seoul International Invention Fair, SIIF, in 2007. Best Commercial Value Award at the Malacca International Intellectual Exposition 2016. In addition to her innovative products, she is also an active consultant that has received numerous research grants from private agencies that needed her professional services. The highest amount of contract research The highest amount of contract research grant received by her from industry is from Jacqueline Floor Specialist, amounting to $250,000, followed by Concrete Society of Malaysia, Academy of Concrete Technology, Nick Jai Associates Sdn Bhd, Temple-Light Insulation Sdn Bhd, YM Microworks Sdn Bhd, Shah Cement Industry Limited, CEA Engineering Consultancy, Soulfly Engineering and Security Sdn Bhd, Natus Lab Sdn Bhd, and Serata Sinar Enterprise, amounting to more than 1.2 million ringgit. Besides project worth millions of ringgit, she is also engaged in outreach program with the Malaysian Investment Development Authority, MIDA, valued at approximately 1 million, and Ipoh City Council for the formulation of blueprint Ipoh towards low carbon city, again with an amount of $250,000 ringgit. Apart from these grants she obtained from industries and private agencies, she has been a principal researcher for many research projects that have received grants from government agencies such as eScience from Ministry of Science, Technology and Innovation, MOSTI, Exploratory Research Grant Scheme, ERGS, Fundamental Research Grant Scheme, FRGS, under the Ministry of Higher Education. She has received research grants and consultancy amounting to more than 5 million ringgit. Ladies and gentlemen, due to her outstanding accomplishment and contribution to research, she has been conferred for 2 consecutive years Innovation Awards, 2001 and 2002, from Bank Islam Malaysia Berhad, the Most Active Research Panel Assessor Award, and an editor for my site Index Journal during the Research Summit Day 2017. She was also awarded a special award from American Concrete Institute, the Malaysian chapter, in appreciation for her contribution to the construction industry. She is also a 3-time recipient of the Excellent Service Award, one in 2002, 2013, and 2020. She was awarded a Tokoh Quality Berterusan or Continuous Quality Icon at the faculty level in 2019. Her designation portrays her active involvement in professional bodies as a Secretary of Concrete Society Malaysia for 10 sessions for 20 years since the year 2000. Committee Treasurer, Secretary since 2007, now holds a position as a Director of American Concrete Institute Malaysian Chapter, and also a member of Institute of Engineering and Technology, IET UK. Based on her expertise, she has been appointed as a Chief Editor for Scientific Research Journal UITM, a member of the Editorial Board for Malaysian Construction Research Journal, CRIM CIDB, the Institution of Engineers Malaysia, IEM Journal, Journal of Engineering Science and Technology, JUSTEC, International Sustainable Construction Journal, co-published by UTHM Concrete Society of Malaysia, and now she is an editor for Journal of Sustainable Civil Engineering and Technology. Ladies and gentlemen, you see that Prof. Hamidah is a well-rounded person. I am certainly honored and privileged to introduce you to her. But I still feel that after reading such a lengthy introduction, justice is not done to her. If you would indulge me, allow me to share what others thought of her as well. So would the technical team play a short montage of Professor Hamidah?
Profesor Hamidah dilahirkan tanggal 9 Oktober 1966 di rumah di Muara Johor. Profesor Hamidah telah mendapat pendidikan awal di Sekolah Rendah Kebangsaan Perempuan Sultan Abu Bakar, Muara Johor dari darjah 1 hingga darjah 6. Beliau kemudian mendapat pendidikan menengah di Sekolah Menengah Perempuan Sultan Abu Bakar, Muara Johor. Beliau kemudian ditawarkan beasiswa Jabatan Perkhidmatan Awam JPA untuk melanjutkan pengajian peringkat sarjana muda di Universiti Miami, Coral Gables, Miami, Florida, Amerika Syarikat dalam bidang kejuruteraan awam iaitu bidang yang beliau minati. Beliau telah kembali ke tanah air dengan segenggam ijazah sarjana muda kejuruteraan awam pada tahun 1988. Kembali dari Amerika Syarikat, beliau telah bertugas di Getah Hindus Sdn Berhad selama 4 tahun sebelum bekerja di Sdn Berhad sebagai penyelidik pada tahun 1992. Pada tahun 1993, beliau sekali lagi telah ditawarkan beasiswa JPA ADB untuk melanjutkan pengajian di peringkat sarjana dan kedoktoran dalam bidang kejuruteraan awam di University New South Wales. Tajuk tesis beliau adalah Durability of Steel and Fiber Reinforced Plastic Embedded in Concrete Containing Silica Film. Beliau telah berjaya menamatkan pengajian peringkat PhD pada tahun 1999. Dan pada tanggal 25 Mac 2000, beliau secara rasminya adalah seorang pensyarah di M45 di Fakulti Kejuruteraan Awam di Universiti Teknologi Mara UiTM. Selepas 2 tahun berkhidmat, beliau telah dilantik sebagai koordinator pengajian Sizwazah dan memegang tugasan itu untuk tempoh 5 tahun. Pada masa yang sama, beliau juga diberi tanggungjawab sebagai koordinator unit penyelidikan dan perundingan UPP kerana beliau sangat aktif dalam penyelidikan dan memperolehi geran dalaman dan juga luar seperti e-science mencecah jutaan ringgit di samping membantu staf FKA mendapat grant. Pada tahun 2008, beliau telah ditugaskan untuk menyediakan kertas kerja penubuhan Pusat Kecemerlangan iaitu Institut Kejuruteraan Infrastruktur dan Pengurusan Mampan. Beliau juga berjaya menggraduatkan 16 orang graduan PhD sama ada sebagai penyelia atau penyelia bersama.
Dan seorang yang boleh membimbing saya.
Antara benda yang masih kekal sampai hari ini yang saya pelajari daripada dia ialah etika dan cara menulis.
Pada 2010 sehingga 2017, beliau diangkat sebagai Ketua Unit Pengurusan Kualiti yang melibatkan beliau dengan amalan terbaik kualiti mematuhi COPPA, COPIA, SWA dan Majlis Akreditasi Kejuruteraan atau EAC dan mengetuai 14 jawatan kuasa kecil di bawahnya. Beliau telah dianugerahkan anugerah tokoh kualiti berterusan peringkat fakulti kerana usaha beliau dalam memperkasakan sistem pengurusan kualiti di FKA pada 2020.
Seorang yang kuat bekerja dan seorang yang menepati waktu, tingkatkan kualiti kerja yang baik, seorang yang berdedikasi.
Ya, beliau adalah seorang pensyarah yang begitu komited dengan pelajar-pelajar dan juga begitu komited dengan Fakulti Kejuruteraan Awam.
Pada 2018, beliau telah dilantik sebagai Timbalan Dekan Penyelidikan dan Jaringan Industri. Kerana kegigihan beliau, FKA telah berjaya memperolehi 6 bintang dalam Maira. Beliau telah dilantik sebagai Dekan Interim sehingga penubuhan KPK secara rasminya pada 29 Mac 2022.
Saya sebagai dekan FKA yang dahulu, saya boleh lepaskan sesuatu tanggungjawab kepada beliau dengan senang hati. Beliau boleh menghasilkan yang terbaik untuk portfolio beliau.
Namun, pada 1 Disember 2021, beliau telah diminta untuk menjalankan tugas Dekan Jaringan Industri, Community dan Alumni ICAN, KPK dan pada 3 Februari beliau dilantik secara rasmi sebagai Dekan ICAN College Pengajian Kejuruteraan.
For those of you who wants to know what is IDAC, orang yang ada ilmu, berdisiplin, amanah, rajin dan bertanggungjawab, look at Prof Hamidah. I wish Prof Hamidah all the best and I hope that your services to your IKM will be rewarded not only here but also in the hereafter.
Saya tahu mak sangat sayangkan anak-anaknya, sanggup berkorban mencari rezeki untuk anak-anak supaya anak-anak kita susah, biarlah mak yang susah.
Prof Hamidah ni adalah seorang yang berketepatan masa dan ini very punctual.
Sayang Kak Mak, semoga Mak terus sukses dan berjaya hingga ke akhir hayat.
Prof. Dr. Hamidah Mohd Saman dengan yang paling sempoi. So ladies and gentlemen, that is our professor, and this is the time now I would like to hand over the session to Prof. Hamidah. Ladies and gentlemen, please allow me to give you the lady, the researcher, the professor, Professor Dr. Hamidah Mohd Saman, who will be talking to us on the future and wonders of floating and living concrete. Prof, welcome.
Thank you, Prof. Suhaimi. Assalamualaikum and salam sejahtera to yang berbahagia Profesor Surveyor Engineer Dr. Suhaimi Abdul Talib, Assistant Vice Chancellor College of Engineering, yang berbahagia Profesor Teknologis Dr. Wardah Tahir, Director of Curriculum Affairs Unit, UITM, yang berbahagia Major General Datuk Pahlawan Engineer Haji Syapiti bin Haji Rizwan, Director General Markas Angkatan Tentera Malaysia, Bahagian Perkhidmatan Kejuruteraan Pertahanan, Datuk IR Ruslan Ahmad Zainuddin, Presiden Civil Engineering Alumni Club, Datuk Teknologis Dr. Ahmad Ruslan Muhammad Rizwan, Orang Kaya Panglima Bukit Gantang, Seri Amar Diraja Ahli Dewan Negeri Perak, Prof. Dr. Zakia Ahmad, the Dean of Research and Innovation College of Engineering, Professor Engineer Dr. Muhammad Azmi Ayub, the Dean of Academic and International, my industry partners, Deans, Deputy Deans, Directors of UITM, representatives from American Concrete Institute Malaysia Chapter, Concrete Society of Malaysia, alumni, my friends from Perwani who always support me, ladies and gentlemen. Concrete is a wonder of man-made concrete. From rocks, hill, mountain, it is transformed to decent or luxurious places for human beings, animals and creatures for their shelter. Concrete can be cast into desired shapes and sizes to produce beautiful structures with high architectural values. Either it is designed using traditional or modern concept. The oldest concrete buildings in Malaysia are durable, still standing, while modern architectural concrete structures have become landmarks of the country. Concrete has evolved since its establishment in 1756 by John Symington, and since then, concrete has been evolving towards blended cement, ultra-high performance concrete, geopolymer towards self-healing concrete, smart, nano, and translucent concrete in 21st century. However, the evolution of concrete comes with challenges, and the challenges can be divided into two categories. First, deterioration, and second, environment and sustainability issues. Concrete deteriorates to external and internal attacks that induce cracks. The cracks allow penetration of liquid that promote deterioration, such as corrosion of steel reinforcement, carbonation, alkali aggregate reaction that all will lead to disintegration and spalling. Meanwhile, huge consumption of natural aggregate, natural resource depletion, and adverse impact to environment become major issues as far as concrete production is concerned. Therefore, concrete needs to be transformed into sustainable technology. Supplementary cementitious materials, or SCM, such as fly ash, rice husk ash, waste paper sludge ash, or WPSA, and ground granulated blast furnace slag, or GGBS, were introduced by researchers in 1980s. When one SCM is used to replace Portland cement, or OPC, it is called binary blended. If two types of SCM are included, it is called ternary blended. To be SCM, the total content of silica oxide, calcium oxide, and aluminium oxide must be higher than 70%, as according to ASTM C618. SCM is also called mineral admixtures. The advantages of using blended cement concrete are in three folds. First, it reduces cement consumption. Secondly, it contributes to early or later strength. And thirdly, it improves durability because of the pozzolanic reactions due to secondary hydration that form additional calcium silicate hydrated product of cement hydration that densify the microstructure of the matrix binder, lead to low permeability. For today's presentation, two parts of Concrete Wonders are deliberated. First part is on lightweight concrete, and second part is bioconcrete. Lightweight concrete is defined as concrete that has density below than 2,000 kg per meter cube. Normal concrete density is 2,400 kg per meter cube. Three types of lightweight concrete can be achieved by three methods. First, by using lightweight aggregate. Second, by introducing expanding agent. And third, by eliminating fine aggregates, or known as no fine concrete. However, only one type of lightweight concrete that I have been working on, which is the one using expanding agent, that is called foam concrete, and will be presented today. The mix proportion from concrete with various densities, an in-house spreadsheet was developed and tested its accuracy in terms of the density of concrete produced. The uniqueness of this spreadsheet is its mixed proportion of an arbitrarily chosen density. The sand-cement ratio and water-cement ratio can be calculated. The spreadsheet can also be used to mix proportion for modified foam concrete and proven accurate with respect to its fresh mortar density before and after adding foaming agent. I would like to show you how the spreadsheet is used. For example, with density 1,600 kg per meter cube, sand cement we set 1 and water cement ratio 0.6. For this spreadsheet, the material used are cement, sand, water, and we can add any other SCM such as WPSA, glass fiber, and also recycled concrete aggregate, provided that we know the values for specific gravity for each ingredient. By using the specific gravity values, the weight of the ingredients can be converted into liter. And this liter for all the ingredients will be totaled up. then this liter will be converted to 1,000 liter, and this spreadsheet, because of the formula already set, it will recalculate automatically for each ingredients used. So give the mortar before adding foam. For targeting density by using this spreadsheet, so the amount of foam and the amount of mortar can be calculated. So if we intend to produce 1 meter cube, or maybe more than that, for example, 2 meter cube, then it will be automatically generate the amount of foam and mortar and also the ingredients for all to make a foam concrete. The quantity of foam agent to be introduced will be set by timer of the machine. The flow rate of the foam that discharge from the machine is initially determined. The timer will be set to control how much foam is needed. We can try another density. For example, we can try less than 1,000, for example, 900 kg per meter cube to make the foam concrete floating. Then we can change water-cement ratio to 0.5. Water-cement 0.5, and we can see the values for the colors one will follow suit, will change. So it is noted that when we target lower density, the amount of foam will be higher. The foam is generated by a machine that is locally fabricated and combined with a compressor, as in the picture, to compress the liquid forming agent into foam and introduce to mortar that made of cement, sand, and water. After mixing, the workability of foam concrete is tested using flow spread test. A comprehensive study covering parameters like different sand-cement ratio, different densities, and two curing regime conditions was conducted under the grant awarded by the Ministry of Science, Technology and Innovation, MOSTI. The study continued with other parameters like different types of foaming agent and introducing byproduct materials to replace cement and use of recycled aggregate to optimize use of cement, and costs were also conducted. The findings are a higher compressive strength was attained by the water-cured specimen indicated by the dotted line than the air-cured specimen. The higher compressive strength is obtained if high cement content is used. The foam concrete with density of 1,000 kg per meter cube can attain compressive strength above 30 MPa if very high cement content is used. Replacing cement by 20% WPSA is not significantly different from those of the corresponding concrete containing only Portland cement at 180 days of age. The inclusion of fine recycled concrete aggregate or FRCA up to 30% boosts the compressive strength than that of control specimens and able to reach about 10 MPa at 180 days of age. Inclusion of both 20% WPSA and 30% FRCA producing an equivalent compressive strength as those of plain foam concrete at 180 days. Collaboration with industries has moved forward the laboratory scale to mass production of foam concrete in producing lightweight blocks and a stay-in-place or SIP hollow formwork, which taken up by this Jaya Concrete Products and Berhad, and solid solid housing solution systems and Mohd, respectively. This SIP formwork is an unremovable formwork, and it will be the internal and external surface of the walls. The hollow space in between will be filled up by foam concrete, and other applications of foam concrete include embankment and foundation filling. Another concrete wonder is about making concrete alive, at the same time prolong its service life. Concrete is alive if living things are included, making it able to self-heal when there is a fissure or crack. Living things refer to microorganisms or bacteria. Concrete that adopts bacteria is also known as bioconcrete. Bacteria in concrete undergo a metabolic activity producing calcium carbonate or calcite precipitation, which has similar properties as rock, and this process is called biomineralization. A study under financial support from Zacklin Floor Specialists was conducted. Two categories of bacteria were used in the study. First category is two species of bacteria, that is Spora sarcina pasteurii and Bacillus subtilis, that were purchased from third-party company. Secondly, three species, H1, N7, and N10, were obtained from soil and hot spring in Malaysia, which is not known its species. However, the three unknown bacteria were sent to third party for DNA sequencing to identify its species. For preparing the bacteria broth solution, it involves 6 activities, which first preparing media. 6 media were used to cultivate the bacteria and determine the most suitable ones for the bacterial growth to formulate the broth solution for crack treatment. These media were experimented to incubate the bacteria at 2 different temperatures for biosolution. A lookful of media with bacteria is poured into Petri dish and keep it overnight. Then the overnight cultures are stripped and are incubated for 24 hours. The growth of the bacteria was observed by the appearance colony on the agar plate and cloudiness of the media broth. The observation shows that the Spora sarcina pasteurii grows well in H4YE at temperature 30 and also 37 Celsius, while Bacillus subtilis grows in all media at both temperatures. For the 3 unidentified bacteria, H1, N7, and N10, it can grow in all media. However, not surprisingly, it only grows well in 37 and 50 Celsius because of the source from hot spring. From the observation under high magnification microscope, the shape of the bacteria cell inferring that the bacteria belongs to either gram-positive or negative family. Gram is the name of scientists that have identified the positive and negative family of bacteria. Only the positive family able to produce calcite precipitation. These are the images of 5 species bacteria chosen in the study that have rod shape inferring it belongs to gram-positive family. That means it falls under category of bacteria that able to produce calcite precipitation. Different concentrations of bacteria with different amount of urea. Urea is a catalyst that bacteria likes to eat, were experimented to determine how much or how many bacterial cells and how much urea is needed for the bacteria to actively produce calcite precipitation. The concentration of bacteria is determined using a nanophotometer through optical density, or in short OD measurement, which implies that the higher amount of bacterial cell, more cloudy the media solution is and cause OD reading to be higher. This is typical growth curve of the bacteria. The lag phase is between 0 to 7 hours. The exponential phase is the phase when the bacteria rapidly grows. Usually it takes about 8 to 44 hours. The stationary phase is between 44 hours to 56 hours, and at this stage, all the nutrients are used up. After 57 hours, the death phase is reached. By knowing this growth phase, it can assist to decide at which hour is the best phase to cultivate the bacterial cell for preparing the broth solution. These are the growth curve for 5 types of the bacteria selected, and it shows that the exponential phase for those bacteria is between 3 to 24 hours. There are 3 methods of test to determine whether the bacteria can produce calcite. First, by gram staining test that I explained earlier. Secondly, by Urey's test. In Urey's test, the solidified broth in urea agar is incubated for 24 hours. The color change from yellow to pink or purple means the urea has been consumed or hydrolyzed to produce ammonia and carbon dioxide, leading to further reaction to produce calcium carbonate or calcite. Another test is by incubating the bacteria in B4 media for 2 weeks. Under microscope, if the precipitation of calcite crystal is formed, it means that the bacteria are capable to produce calcite. It is confirmed as the crystal preparation appear for those plates that contain mix of B4 and the bacteria. However, no crystal precipitation appear in the one in control plate. From DNA sequencing test, the unknown bacteria is identified as species by electrophoresis process from the nucleotide sequence and inserted into the National Center Bacteriology Information or NCBI website. The species of bacteria can be identified. So the 3 unknown bacteria are found to be Bacillus proteolyticus for H1 and for N7 and N10, both are come from Aeruginoebacillus thermoaerophilus species. If we like to name our children with very long name, bacteria also have a long name. 2 types of specimen were used to create artificial cracks. One is on mortar and another is on concrete, just to distinguish the difference of 2 in terms of healing process. Both the mortar and concrete specimens were cured in water for 28 days. 2 methods were adopted to create artificial crack on mortar and concrete specimens. First method, the cracks were made by applying a load to the specimen using universal testing machine or UTM. The crack width created are in the range between 0.1 mm to 0.3 mm. However, by using this method, the crack width and depth cannot be controlled. To obtain consistent crack width and depth, another method is used, which is by inserting a thin aluminum plate with the size of 3 cm wide and 2 cm deep and 0.3 millimeter thickness. Experiment on concrete cracks was performed. 3 types of broth solution were prepared containing bacteria Spora sarcina pasteurii that were taken from 3 different growth phases of its incubation. One was taken when it just passes lag phase at 24 hours as specimen 1, at exponential phase 33 hours and 48 hours before reaching stationary phase as specimen 2 and specimen 3 respectively, with different number of bacterial cells in it. The brown solution made of Spora sarcina pasteurii was injected into the crack created using 1 ml dropper and monitored for 7, 14, 21, and 28 days. It shows that the crack treated with broth containing highest bacterial cell, or 2.88 times 10 to the power 9 cell per mil, was filled up at 21 days. The healing efficiency reached 100% at 28 days, and the one treated with highest number of bacterial cell, which is specimen 3, reached 100% healing earlier. No calcite precipitation was formed on the non-treated crack. Another work on mortar was also conducted at the laboratory scale. It was found that the cracks were fully filled up at 28 days after treated with 10 ml of 1 times 10 to the power 10 cell per mil of Spora sarcina pasteurii bacteria. Based on the different bacterial cell concentration put in the broth solution and expressed in OD reading at 600 wavelength, it shows that the broth recorded 0.6 to 0.8 OD cell concentration is sufficient to get full healing at 28 days. The healing process was monitored. It shows that at 7 days, fully healing is achieved for the cracks treated with the broth bacterial solution that records 0.6 OD reading. Similar goes to 7 days and also 10 days. At 28 days after treatment, fully healing are seen for those treated with bacterial broth solution that recorded 0.2, 0.4 up to 0.8. Contrastively, for 1 OD, it remained unhealed due to the overpopulation of the bacteria, which led to a faster death phase and lesser calcite formation. Other broth solutions that made of Bacillus proteolyticus, Bacillus subtilis, and Aeruginobacillus thermoaerophilus were also experimented with same amount and same concentration of bacterial cell. Similarly, the full healing is achieved at 14 days and above after treatment. There is intention to improve the healing efficiency time by adding urea, which is a catalyst to promote more formation of calcium carbonate from the bacterial hydrolysis. In many cases, it shows that the broth solutions with urea addition do accelerate the healing process. Other series of studies utilizing Bacillus subtilis broth solution with and without urea were conducted. Similarly, the full healing is achieved at 14 days. The concentration of 10 to the power 8 cell per mil was found the best concentration to treat the cracks. Similarly to Bacillus proteolyticus, the cracks treated with and without urea for 1 milliliter broth solution were found to achieve full healing at 14 days. It was observed that the cracks treated with Aeruginobacillus thermoaerophilus N7 and N10 broth solution with and without urea also achieved full healing at 14 days. Concentration as low as OD 0.2 reading of Aeruginobacillus was found enough to full heal the cracks in mortar. Nevertheless, the good about Aeruginobacillus thermophilus, it shows sign that the cracks start to fill up as early as 3 days after the treatment. The mineralogical composition of calcium carbonate or calcite crystal filling material in the cracks was carried out by X-ray diffractometer or SRD. From the SRD analysis, all the bacteria isolates, namely Spora salsina pasteuri, Bacillus subtilis, Bacillus proteolyticus, and 2 and 7 and 10, Aerurinibacillus thermophilus, show the production of crystal through the appearance of the intensity of the peaks. The white precipitation of filling materials in the crack sample was scrapped and crushed after 28 days observation, sieved to minimize the sample size, and then was examined under scanning electron microscope or SCM. The filling materials were examined under SCM. It shows the morphology of the filling materials were identical to the morphology of the standard calcium carbonate crystals. Therefore, it was confirmed that the calcium carbonate or calcite in the cracks were actually produced by the bacteria. Now, to visualize the works that have been done, please watch the video. Managing Director of Jaya Concrete Products in Mohd, and my right side, Mr. Alex Liu Chapman, the owner of Solid Housing Solutions. We have been working together to study, to explore the use of hot concrete in construction since 2002 for the past 20 years. The forming agent is categorized into two types, namely synthetic base and also protein base. This is the chemical or the synthetic forming agent that already diluted and ready to be used to generate and to compress to produce forming agent. 1 liter cube mortar, 1,400 kg sand is needed, and cement is 650 kg, while the water is 145 L. And this is to produce about 900 kg per meter cube density of foam concrete. The mortar mix is poured into the known volume of container, then weight this container, then fill with the mortar, then the density will be calculated. After the foam is added and mixed, so the density of the foam concrete is determined. As conclusions, concrete has created wonders throughout the evolution while the solutions for the issues are being provided. The solutions like use of SCM by product base and recycle aggregate bioconcrete are examples of concrete evolution to reduce the use of cement and natural aggregates and improve the durability of concrete. Plain form concrete can be modified by utilizing WPSA, the paper industry byproduct, and recycled concrete aggregate or RAC, although it does not contribute much to compressive strength, but it can reduce the consumption of cement and natural sand. It is proven that bacteria isolate from local hot spring and soil have the potential as a medium of healing concrete cracks. Eventually, bacteria broth was formulated to treat cracks within shortest time. In my presentation, two evaluations of concrete emphasize the need to incorporate the science of multidisciplinary to find solutions that will be impactful on the environment and ensure sustainability. This concrete technology would initiate collaboration that will benefit academia, manufacturers, industries, and the public. Before I end my presentation, I would like to take this opportunity from the bottom of my heart to thank all those who have supported me throughout my journey. I may not be able to mention all, to name a few. First, to Professor, Engineer, Surveyor Dr. Soimi for pushing me to make this event a reality. My ex-dean, Professor Datin Dr. Zainab Muhammad, Professor Dr. Azmi Ibrahim, and Professor Dr. Zakia for their coaching. My industry partners, Mr. Awi Shahdan, Mr. Alex, and Dr. Zack Lim for their moral, materials, and financial support for my research. My friend from American Concrete Institute, Malaysia chapter, Eric, Alex, Mike, Katiravan, Oscar, and his colleagues. The ex-president of Concrete Society of CSM, Datuk Wira Abu Bakar Muhammadiyah, and Datuk Technologist Dr. Ahmad Roslan, Datuk Engineer Roslan Ahmad Zainuddin, President of Alumni Civil Engineering, UITM, who always be my mentor. My good friend, Puan Seri Haniza Abdul Hamid, who always give me motherly advice and comfort. Thank you. Dr. Kartini, Dr. Mazida, and Dr. Juraida for always be with me during my hard and difficult time. My friends from Perwani, who always cheer me up when I am in needs. My PhD graduates, Dr. Mazna, Dr. Radin, Dr. Mazuki, Dr. Rosaina, Dr. Nohasri, Dr. Izzat, Dr. Nuli, Dr. Zalipa, Dr. Zaizatul Akmal, Dr. Ani, Dr. Muhammad Faizal, Dr. Aiman, and Afufuddin, who present today to support me. All members from School of Civil Engineering, organizing committee members led by Associate Professor T.S. Dr. Cik Khairil Izam, Cik Ibrahim, and Dr. Muhammad Khairul. All my industry partners in the concrete circle, my staff from ICANN, and lastly, not forget, my family, especially my children and my husband, Major Muhammad Zakwan Muhammad Nur, for his inspiration and motivation for me to move and continue my journey. I also would like to acknowledge and highly appreciate to my new collaborators yang berbahagia Major General Datuk Pahlawan, Engineer Haji Chapiti Rizwan, and Engineer Razali Budin, Vice President Tamko, Switchgear Malaysia Sdn Bhd for coming today. And I really hope collaboration happen between College of Engineering UiTM with Malaysian Armed Forces and TAMCO Switchgear Malaysia Sdn Bhd. With that, I end my presentation. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Thank you.
Ladies and gentlemen, the committee would like to thank Yang Berbahagia Professor Dr. Hajah Hamidah Muhammad Saman, Dean of Industry, Community and Alumni Network, College of Engineering UiTM, for the great lecture and knowledge sharing. Let's give a big applause to Yang Berbahagia Prof. Hamidah. While Prof will remain on the stage for the next agenda. Now, we would like to invite Yang Berbahagia, Professor Surveyor, Engineer, Dr. Haji Suhaimi Abdul Talib, Assistant Vice Chancellor, College of Engineering, to be on the stage. Please welcome Prof. As mentioned earlier in our event, beside the research on today's Prof. Hamidah lecture, we also have a special quiz on gauging the mass and the density of the concrete as displayed outside. As for that, I have two names with me, and for those who were guessing them right. Without further ado, we would like to invite Yang Berbahagia, Professor Surveyor, Engineer Dr. Haji Suhaimi, to give away special prize for the winners. For guessing the mass of the concrete, the winner is Adibah Muhammad Othman from Assistant Vice Chancellor Office. Congratulations. For guessing the density of the concrete, the winner is Zainul Shahira, HR Executive from SHRDC. Please welcome. Congratulations to both our winners. Ladies and gentlemen, the committee has prepared a small token to our honored speaker. And we are pleased to invite Yang Berbahagia, Professor Surveyor Engineer Dr. Haji Suhaimi, to give away a token of appreciation to Yang Berbahagia, Prof. Hamidah. Thank you, Prof. And now, we would like to invite all VIPs to be on stage for the photography session. Please welcome.
Sebab belakang tak ada banner, tak ada banner.
Next, we would like to welcome others industry partners to join the group photo on stage. Please welcome. Okay, thank you very much to all the honorable guests, and please have a seat.